Okay, on to the last question, question 6. So for the first part here, we have if 10 megabit per second Ethernet speed is used, what is the apparent bandwidth for host 1? So host 1 is right there. We want to know what that looks like. We've got a switch here, which switches sort of divide it such that the host is kind of the only thing on that network. It's just divided by that switch and the host itself, right? And then we've got a bridge connected here. So the sort of connection domain for this host 1 is right like this. And we sort of ignore the switch in this particular configuration. And so we've got the bridge that's connected to it, and we've got the host that's connected to it. So we've got our 10 megabit per second divided by 2 for a total of 5 megabits per second for that host. So really just knowing the rules for bridges and switches in the network. If we remove the two switches and replace them with hubs, hubs are effectively just wires, right? So now all of these things are connected together and they're sharing the same domain. So for part 2, we have to think about the fact that we're now looping in hosts 3 and host 2 into this. So now we have 10 megabits per second divided by, instead of the switch sort of cleanly giving each of these their own domain, we now have 4 hosts on that domain. And so we have 2.5 megabits per second instead. Okay. So moving on to part C, D, and E, we're now looking at an Ethernet frame, layer 2, no preamble, which is transmitted on the network. Based on the diagram above, which host is this frame coming from, and which is it addressed to destination. So here we need the format for the frame that's given to us with the exam, and we need to remember the rule that 1 byte equals 2 hex, right? We also might want to remember the rule eventually that 4 bits equals 1 hex, right? So to read this, we've got 6 bytes of destination address. So 1, 2, 3, 4, 5, 6. That whole thing is my destination. 1, 2, 3, 4, 5, 6 more bytes is going to be my source. And that's just, again, sort of reading this format. The next 2 I'm just going to sort of do are length or type. And then after that, we have our data and padding. So our data starts there. And then at the end, presumably, we've got our frame. So this is our CRC from the format here, those last 4 bytes that we have. So that's all we really need that part of this for, is just to know what exactly is there. So we can look then, given the bits we have here, we can look at this as, basically colons between each of these things. So we look up at our diagram and see, okay, where is D8, C7, C8, 77, 88, 99, and that's our source. So if we look at the chart, we see that is our MAC address for, just looking I think this is flipped on the key that you have here. So host 6 is D8, C7, C8, 77, 88, 99. So our destination host is host 6. So for the key, this should be flipped from what it is. And then the source host is D8, C7, C8, A, B, C, D, E, F. That's host 3 is our source host. So again, just reading that format and making sure we match up the correct MAC addresses with what we see there. Part D, the frame from part C uses the minimum amount of data and padding. What is the ratio of data and padding to total frame size? So again, we need to think about what that format looks like, right? And so here we've got the format, and we've got our data and padding minimum size is 46 bytes there. So our minimum size is going to be 46 bytes. Divided by, we want the ratio of data and padding to total frame size. So we're dividing this by the total size. So 46 plus 4 gets us to 50, plus 2 is 52, plus 6 is 58, plus another 6, that's 64 bytes. So that's the sort of total size of everything listed there, including that 46 that we used earlier. and then if we do that ratio, it should be 71.8%. So this is just using that format, understanding what's supposed to be there. And then the next question, the data uses the ASCII, or is encoded using ASCII, decode that message. So we have this whole, we've identified where the data is previously, so everything listed here is going to be part of that data. And we can see that it sort of ends in a null, that's not really what happens. It's not the same as C strings, though. We can kind of consider that like zeros are not actually data anymore. So we need to use our ASCII table and convert each of those to the character that they are. And it goes just in order, so it's pretty simple. So 48 is capital H. And as we continue across, you should find that this is short for hello. And then the 20 is a space. 57 is world, or the beginning of world. And we get to the 21 here. That is an exclamation point, and that's the end of it. So that's our message that was sent across this frame. So again, really just the biggest part of that last question is identifying where the data is. We sort of did that already by looking at this format here and understanding that each 2 digits of hex, or each group of 2 here is a single byte. So we can sort of count across to where the data and padding starts. And then understand that it's encoded in ASCII. So that's it. Good luck with the exam.